Hello again, our most valued student. My name is Confident. Welcome to our revision session, and today we are looking at complex numbers, and this is covered in Mathematics N4. So I took a question from one of the previous papers, and I just wanted to look at only one question on complex numbers, and we're going to do a series of these, and I want you to watch out for part 1. This is part 1. So I want you to watch out for part 2, part 3, part 4, even part 5. And as I said, we will be focusing solely on complex numbers. So let us look at this question. This is question 1. It says you need to solve for x and y if you are given this equation. Now, whenever you are looking at complex numbers, you have got two formulas that you can use from the formula sheet. And this is what you're given. If you are dealing with complex numbers and you are solving, you can use these two equations. The first equation actually that we're going to use is this one, which is a plus bj is equal to c plus dj. So now what is happening in this case is this is what they are saying. If you're solving for complex numbers, if you have got such a situation, therefore a is equal to c, these are the real numbers part, and b is equal to d, which is the imaginary side. But we're going to all do that whenever we're now solving the equations. So let us go on and look at the equation given, and I'm going to show you 2 or 3 different approaches that we can use to solve for x and y. So let me write this on a fresh page. So what I'm given here, if I can write it, so what I'm given here, you're saying x plus jy, which is x plus jy is equal to, and then you have got 5 plus j7 all over, and then we have got 1 minus j. So this is 5 marks, and you want to ensure that you get all the 5 marks in this case. So what is the first approach that I usually use? Okay, before I do anything in this case, let me just show you a little bit of some working that I do. So the first thing is, if I'm given j7 here, you must know how to simplify it. So the first part is, if you are given j squared, remember j squared is same as okay, let me start from the bottom. Remember j is square root of minus 1, therefore j squared is square root of minus 1 squared. And in this case, this will be equal to, now if you say square root of minus 1 times square root of minus 1, you're going to get minus 1. Remember that. And then if I give you now j to the power of 4, this is same as square root of minus 1 to the power of 4, which is equal to square root of minus 1 squared times square root of minus 1 squared. Now, from here, we said j squared is square root of minus 1 squared, which is negative 1. So you're going to have minus 1 times minus 1, which is equal to a positive 1. Therefore, we conclude that j squared is equal to minus 1, and j to the power 4 is equal to positive 1. Now, what about j to the power of 7? If I want to simplify j to the power of 7, this is equal to j to the power of 4. Remember, in 7 there is 4. Now, using laws of exponents, times j to the power of 2 times j to the power of 1. This can give me 4. So I'm expressing it in terms of 4, in terms of 2, and in terms of 1. So when I'm simplifying that, I will be then saying, since j squared is minus 1 and j4 is 1, so this is equal to 1 times minus 1 times j to the power of 1, which is equal to minus j. So that's what I'll be having. And if I therefore come here to simplify, it will be x plus jy. Remember, you need to show your working is equal to 5 plus j4 times j3 times j, and this is all over 1 minus j. So if we continue, we've got x plus jy is equal to 5, as we simplified, minus j over 1 minus j. So we have this. That is where you first need to take into. You have to take it from here, and from here there are different methods that you can focus on. And the first one I'm going to use, if I can focus on the first method, to say x plus jy is equal to 5 minus j over 1 minus j. So I'm going to use the rationalization method. So that's the one I'm going to use. I'm going to rationalize here. Now, if I'm going to rationalize, remember these are complex numbers, and when you're talking about complex numbers, we're talking about square root. If I'm given, for example, if I have 1 over square root of 2, and I must rationalize that, it is 1 over square root of 2, which is square root of 2 over square root of 2. Now, to rationalize is to get rid of the square root, which will be 1 square root of 2, which is simple square root of 2 over square root of 2 times square root of 2 is 2. So this is what I have done to rationalize. Even your calculator, if you say 1 over root 2, here 1 over square root of 2, your calculator rationalizes automatically to give you square root of 2 over 2. What about if I give you now in a complex form, and I say you have got 1 over square root of minus 1, so, or minus 2 for argument's sake. So this will be equal to 1 over square root of minus 2. You multiply by square root of negative 2 over square root of negative 2. You say that, and then if you do that, you're going to have now square root of negative 2 at the top over, now square root of negative 2 times square root of negative 2 at the bottom is minus 2. So you see what we have done, we have managed to rationalize. But now with the complex numbers, this will be equal to, remember square root of negative 2 is j2 over minus 2. So you see what you have, or you'll have minus j2 over 2 in that particular case. So now when we rationalize, however, the denominator in this case here, what we need to do when we rationalize the denominator in this case, however, we have to multiply in here by the conjugate of 1 minus j, and by saying conjugate, it is a matter of interchanging signs. So if you've got 1 minus j, you multiply by 1 plus j. So that's what you multiply. The bottom, what you do on the bottom, you also do on the top, 1 plus j. Remember, you multiply by the conjugate. So in this case, if it was normal rationalization with a square root, if I say to you rationalize 1 over square root of 2 plus 1, you're going to multiply by square root of 2 minus 1 over square root of 2 minus 1. This is the conjugate. You interchange the sign from positive to negative, and it makes it a difference of 2 squares. So when you do that and you multiply, what you're going to have is x plus jy is equal to, so we are multiplying now, and just like opening any bracket, you're going to multiply that, and you multiply that, and you multiply that, and you multiply that. So we're just opening brackets here, normal expansion. So 5 times 1, which is 5, and then 5 times j, which is equal to j5, and minus j times 1, which is minus j, and minus j times j, which is minus j squared. And then you divide that by, now remember this is a difference of 2 squares, but anyway, I'm going to multiply all of it, but in difference of 2 squares, you are simply multiplying the first as well as the last, because the center ones are going to separate. But let's multiply them and expand normally, and so that you can see what I mean. So this is 1 times 1, which is 1, and then 1 times j, which is plus j, minus j times 1, which is minus j, and minus j times j, which is minus j squared. So you see what I mean when I say you multiply the first and the last, because plus j minus j will simply give you the 0. So what you do, you have got x plus jy is equal to, so you have got 5 plus j5 minus j. Now remember we said j squared was equal to minus 1, we just did it here. So I'm going to have here minus 1 over, which is 1. Now I've got, actually I must correct this, be careful here. So I've got the negative sign here, so it's minus, then j squared is bracket minus 1. So be careful of that. Similarly at the bottom I've got the negative sign here, and j squared is also a negative 1. So you need just to be extra careful there so that you don't get a 0 at the bottom. So x plus y is equal to, when we simplify, this is 5. Now minus minus 1 will give us a positive there. So it's 5 plus 1. I'm collecting real terms. These are the real terms, which is the real numbers, and the imaginary one are the ones with j, which is 5 minus j, which is plus j5 minus j. So I just collected like terms over, this at the bottom is 1 plus 1, because the minus minus just give us a 1. So you have got x plus jy is equal to, in this case 5 plus 1, we are getting a 6, and then plus 5 minus 5j minus j, which is 4j over 2. Are you seeing that? And then at this stage we can distribute the 2, because the 2 affects the 4 and the 6 separately, which is x plus jy, which is 6 over 2 plus 4 over 2j. And then when we simplify that further, we are going to have x plus jy is equal to, there we've got 3, and there we've got 2. So this is 3 plus 2j. Now when we have reached this part, the next thing to do is to compare. As I said, with the equation, we are now here to say, if you are given a plus bj is equal to c plus dj, look what they say. They are saying a is equal to c, which means the real ones, you compare the real ones, a is equal to c, and with the imaginary ones, b is equal to d. So that's what we're going to also do here. We're going to compare x and 3, these are the real ones, and the ones with j, it's y and 2. So when you conclude, you can say that therefore x is equal to 3 and y is equal to 2. So that is how you conclude as your answer for x and y. So that is how you solve this particular question. But now, what if you wanted to approach this in another way? I'm going to take it, as I said, I will take it from this part, which is x plus j. Let's approach it in another way here to say, if I had it differently, it's x plus jy was equal to 5 minus j over 1 minus j. So we had this simplified, it was j7, but we had this simplified. You can just, if you remember, we took it from here, simplified it into that. So when I've got at this stage now, I say there are different approaches you can use. Now what if I choose, in this case, to multiply by 1 minus j, but what you do on the left, you do on the right, you also multiply this side by 1 minus j. So what you have, you'll be having, in this case, x plus jy and you multiply by 1 minus j, which is equal to 5 minus j. Remember, when you multiply now, this and this goes off. That is what you'll be having on the other side, which is simple 5 minus j. So when you get that, you have now to expand, and let us expand the left hand side. You have got that x multiplies, or you distribute x and you distribute also jy in that case. So what you have is x times 1, which is x, then x minus j, which is minus jx, and then jy times 1, which is plus jy, and then jy times minus j, which is negative j squared y, is equal to 5 minus j. Now when you've done that, you simplify j squared further, which is x minus jx plus jy. Now if you remember, we said j squared here was simple minus 1. So you do the same thing here, where you are going to have minus bracket minus 1, because you've got the negative of that, and then minus 1y is equal to 5 minus j. So we simplify it, is x, and then minus jx plus jy, and then plus y is equal to 5 minus j. Now when we have done this, we are also going to compare the imaginary ones with the real ones. Now look at this. I have got x, which is the real one, and then I've got y, and then I've got 5. These are the real parts. So what I have is x plus y is equal to 5. This is equation 1. So you're using the simultaneous equation here. Now the next one, we are comparing, in this case, the imaginary ones, which is j and j and j. So what we have is, we have got, just drop out the j. So when you leave the j, you see that there is minus x, and then at the same time leave out the j, you see that we have got plus y is equal to, now there is a 1 there that is hidden, which is minus 1, and this is equation 2. So that's what we are having, simultaneous equations, and you know how to solve them. At this stage, what you need to do, you need to add this equation. So we are adding equation 1 plus 2. So when you add x plus minus x, this gives us a 0. So what we have, y, okay, let me just do it, x plus negative x, then plus y is equal to 5 plus minus 1. So it's simple basic algebra. If you did simultaneous, then this goes off. Y plus y, we have got 2y is equal to 5 minus 1, which is 4, divided by 2. In this case, what you have is your y is equal to 2. Then the other one, you take it to any equation. For example, equation 1, which was x plus y is equal to 5. Now you know the value of y, which is x plus 2 is equal to 5, and x will be 5 minus 2, and x will be equal to 3. Now these are the same answers that we did get in that part. So that is how you can solve this question. That was method 2. And what if we are going to let me try now method 3, where we're going to use polar formation, or polar, in a way, this where polar coordinates, where I'm using the angle as well as let me just take it from here again. Okay, let's take it from here. So I've got x plus y, just to see the other method I'm talking about. I've got x plus, if I can use a different pen now, I've got in this case x plus y is equal to 5 minus j over 1 minus j. So let us just confirm that. All right, so this is what we have, and in this scenario I just want us to maybe work on it from the concept of polar coordinates, and you can use a calculator in this case. So the first part is to convert 5 minus j into polar coordinates, and you can use a calculator. So if I've got 5 minus j here, what will it convert to? So 5 minus j is equal to, if I can do that to say what is 5 minus j. So what I do is shift. Remember, I'm converting to polar, so I've got that, which is in this case 5, and then shift comma, and then j there is minus 1, remember, so it's negative 1. And then when I do that, what I have is, see, r is equal to 5 comma 0 into 3 decimal places, 5,099, and then theta is minus 11 comma 3099. So if I convert these to 3 decimal places, I've got roughly about 5,099, and I've got minus 11,30 or 11,310. Okay, so it's negative, so I've got 5 in here. When I convert it to polar coordinates, I've got in this case r is equal to 5,099, and then theta is equal to minus 11, if I check it again, it is 11,3099, which is 11, minus 11,310. So I've got minus 11,310. So that is the first part of converting this. What about 1 minus j? If I'm converting that one, so use something different. If I'm converting 1 minus j into polar form, so what I have in this case, so it's shift polar 1, and then shift comma, and then I've got minus 1. So I'm converting that one. What I have, r is 1,414 to 3 decimal places, and theta is equal to minus 45. So theta is simple there, it's minus 45, but r is equal to 1,414. So we've got r here is equal to 1,414, and I've got theta is equal to minus 45. So this is what I'm having now. And if I then write x, taking it back, I've got x plus jy is equal to, now where there is 5 minus j, how do I write it? Remember, now I'm converting from a rectangular form into a polar form. So if I'm converting it to a polar form, how do you write it? If you go up to the previous part on our formula here, this is in a way, forget about the if we look at the formula here to say, when we're talking about the rectangular form, so we're talking about r, and then we have got that theta. So this is the rectangular form. So if I'm using it here, so my r in this case, so the way is to put it as r and then to put the value of theta. So what I have, my r is equal to, in this case it is 5,099, and then my theta is minus 11,310. So that's the first part. And then remember, I'm dividing by 1 minus j, which became r is equal to 1,414, and then I've got minus 45 in this case. So that's what I'm having here. And if I simplify that, I've got now x plus jy is equal to. So when you are simplifying now the polar forms, what you need to know is when you're dividing the numbers, you are going to have 5,099 over 1,414. So when you have, for example, x theta 1 over, let's call it x1, and then you've got x2, and then you've got theta 2. This, when you simplify division, you're going to take x1 over x2, and then you're going to have your theta. Then you're going to have the top one, which is theta 1, minus, because of division you separate, minus theta 2. That's what we're going to have. So in this case, I'm going to have now minus 11,310 minus 45. I hope you see what's happening there. And then when I simplify, I'm saying minus 45 because there are two negatives. Division, I must subtract, and then the negative of 45. So when I do that, let me use my calculator now to divide here 5,099 over 1,414, and then this gives me 3,606. So I've got 3,606, and then I've got here minus 11,310 minus 45, and see what it gives me. It gives me 33,69. 33,69. Remember, these are angles. This is an angle which is degrees in this case. So when I have done this, so this is x plus jy. This does not make sense because I've got the rectangular form mixed with, in this case, I've got polar form. So I must convert this back into rectangular form. So I've got x plus jy is equal to, so you take again the calculator to convert from polar to rectangular, which is shift. You've got now REC, which is rectangular. You've got these numbers 3,606, and then shift comma, and then you've got 33,69. So when you do that, equal to, so you've got x, you can see x is equal to 3,0000, which is 3 decimal places is more like 3,0. Of course, there are other numbers because we're rounding off, but you can see that it actually gives us x is equal to 3. And then when you look for y, similarly, y is equal to 2,0002. So this is same as x is equal to 3 and y is equal to 2. So you're going to therefore simplify here to say, therefore x is equal to 3 and y is equal to 2. But how do you write it? When you're writing it, you have to write it, remember, into rectangular form. So we are going to have here 2, I think x was 3, so it's 3x plus j2. So that's what you have, so that you can conclude that x is equal to 3, y is equal to 2, so that you can conclude that. So this is converting it from polar to rectangular form. So now that is what I wanted to show you guys, to say whenever you're solving a question like this, it's 5 marks of course, but there are 3 different approaches that you can use, and the one that I prefer mainly is, I prefer actually method 2, the one in yellow. So this is what I prefer as the much simpler one, where I normally expand, and then after expanding I just compare, and then this is the method that I prefer. Method 1 and method 2 are all good. Method 2 is much quicker, as you can see. It's just a short method, but you need to understand your conversions and understand your rounding off, because if you round off in a way, you might end up losing the answers. As well as method 1 is also a matter of rationalizing. That's the most common one that examiners prefer. They prefer this method. That's what you usually find in the memorandum. They prefer method 1, but as I said, you are not limited to that method. Now guys, we've come to the end of our lesson. As I said, I'm going to do a series of these questions. It is very important for you to go through these so that you can get all the information you need about complex numbers. Now, I'll encourage you to subscribe to our channel if you have not subscribed, as well as share this channel with your friends and colleagues so that they can also benefit from this. I wish you all the best as you prepare for your final exams. Thank you.